welcome back to Explore Electronics. In the previous video, we have already covered the topics such as strings and two-dimensional arrays. So, in today's video, we are going to cover another more concepts from chapter 1 of module 3. Those are multidimensional arrays, array initializations, and variable length arrays. So, before we start, make sure you have your notebook and pen ready. Note down the key points as we go along. These notes will really help you during your exams and serves as quick revision keynote later. So, now let us move on to today's first concept. That is, today's first concept is multidimensional arrays. Firstly, in the previous videos, we have already learned about one-dimensional arrays and also a two-dimensional array. So now we are going to learn about multi-dimensional array. Multi, the name itself says multi means what? Many. Dimensions means the size, which has many size or many dimensions. That we call it as multi-dimensional arrays. How it look like then? It look like in this form. First will be type. The data type, it may be a int, float, or double, anything. And the next will be name of an array. And this is size 1, size 2. As we mentioned, it is a multi-dimensional. It can be up to n values. We can't restrict to one thing. So here up to size n we have taken. This is how multi-dimensional arrays looks like. Arrays with many dimensions use a lot of memory. Here is an example. A four-dimensional array int, char, that is a data type, and A is a array name, and these are the dimensions of array. It needs how many bits of memory it needs? Bytes of memory, that is 1160 bytes. Memory depends on data type, right? For char, it's considered as 1 byte each, and for int, it is considered as 4320 bytes for same array, right? And double, it is multiplied by 8 again. Okay, then therefore, we can say the memory allocation or how much memory it occupies mainly depends on the data type which we will be using in a constructing an array. Adding more dimension increases more memory very quickly, exponentially. Right here, you can see the changes from int to double. Here 2 bytes and here it's 8 bytes. Oh, yeah, quickly it has increased. Here is an example. Adding a fifth dimension of size 10. It is the value will become 1,72,800 bytes. So, but this is an advantage part, but it also has a disadvantages. What is that? Access elements in higher dimensional array is slower because the computer must calculate multiple indexes, right? If I suppose, if I write many values, 10, 11, 12, whatever, if I write like this, the size, it has to go through each element, then it has to search or calculate the value, means which the user has given. So it has to calculate multiple indexes. So this is a disadvantages. Okay, when you pass multi-dimensional array to a function, you must specify all dimension except the first. For example, here is an example, data type, array name, and sizes. Then a function receiving it look like void function in D365. Here, they are trying to tell that you can include the first dimension too, but it is not required. In the sense, the mentioning of dimension of first is not required. If you don't mention also, the compiler will what we can say, the compiler will take it automatically. The value will be taken automatically by the compiler. No need to mention while mentioning the size of an array. Here, indexing pointers. Here we can see how pointers are related to array. They are closely related. How? Let us see here. As you know, an array name without an index is a pointer to the first element in an array. In the previous videos also we have discussed how it is considered as first element in the array, but here they have given with example they have explained, and this is a short concept. Here char p of 10, right? Here this can be expressed in this way. The following statements are identical. Here char p of 10. Here by using these two ways, both are identical. Here as I said, hash, it says or it indicates address. Star, the pointer, it says value. Wherever you use this in a program, the same thing comes. Okay? The following statements are identical. Here, P ampersand P of 0. This is also same. This can be written in another way. How is it? P is equal to. Here, equal operator is used. Ampersand P of 10. Both are same. Evaluates to true because the address of the first element of an array is the same as address of the array. Okay, fine. Therefore, we can say that array name without an index acts like a pointer to its first element. A pointer can be indexed just like an array. Here is an example. P of 5 is equal to 100 and star P plus 5 is equal to 100. Here, both the statements assign 100 to which element? To sixth element of the array. The same pointer array relationship applies to multidimensional array. Here, integer array A of 10 and A of 10. Here, which is equivalent A of 0 and 0. Here, element access form. How we are going to access an element? Here, you can see, please take down this A04, which is equivalent star int star A plus 4. How we wrote here? Here is a general form for a 2D array. A, J, K. Okay, which is equivalent to star, the pointer symbol, base type, which is its int, float, double. Then star, then A plus J multiplied by row length plus K. Here star, int, and again star, and again A. By calculating this, they have written at once 12 here. I think you got this. How we have taken this equivalent forms. Here, a cache to base type pointer like int or star A is required for pointer arithmetic to work correctly. Pointers may be used for accessing array because pointers arithmetic is often faster than array indexing. Here, 2D array is treated as pointer to a 1D array to access row. To access specific row means suppose I want to access 10th row. Means specifically I'm saying it. During that time, use pointer to first element of that row. Example, P is equal to int star ampersand num j0. Here, row printing loop, for loop, printf. It goes on printing the values and here it repeats the statement. The row printing function can be generalized using parameters. There are three parameters mainly considered. Those are the row number, row length, and pointer to the first element. Here is an shortened initialization that a character array which holds string in it. Okay, char, array name, and here is size and string. Here, for example, this code fragments initializes str to the phrase I like C, char str of 9, I like C. Here, calculate 1, 2, 3, and 4, 5, 6, 7, and 8. Means after one string as it ends with a null character, even that is included. This is same as writing. This can be written in this way. That is, as I said, character will be mentioned in single quote and string will be mentioned by using a double quote. Fine. Here, as it is a characters, I'll mention first is and after a character, now that word, that string is over. Then it should ends with a null character. Then it should start with L. See here, L-I-K-E. Again, it is ended with here empty. Empty means nothing, null character. Again, C, and it ends with null character because here they have given the explanation the same way what I said. It's a textbook copy, so I have pasted. It is easy for you to understand also. So I have pasted that textbook snap itself. Here, because strings end with a null, you must make sure that array you declare is long enough to include the null. This is why str is 9 characters long even though I like C is only 8. We have counted here, right? How much we got? 8. When you use the string constant, the compiler automatically supplies to null terminator. Means when we use constant in a string, it automatically takes to null terminator. Okay, as it is taken here. Fine. Now, here, multidimensional arrays are initialized the same as single-dimensional ones. For example, the following initializes squares with the numbers 1 through 10. Their squares. Here, data type and square is an array number and here is a size 10 and 2. Okay. Flower brackets 1. 1 square is 1, 2 square is 4 and 3 square is 9. In the same way, it has gone through. This is how multi-dimensional arrays initialize the same as single-dimensional ones, right? Here open braces and by use we have separated the elements by using comma. But to show the squaring part, we have mentioned it row wise. Okay, you can observe here. This can be expressed in another way. How is it? Let us see that. In the same way, here, when initializing multi-dimensional array, you may add braces around the initializers for each dimension. This is called as aggregate grouping. For example, here is an example. Here, data type and square is array name and this is the size. Here, each value and its square is enclosed with the flower braces. 2 square value is 4 and 3 square is 9. In the same way, after going through up to 10, again it is enclosed with flower braces, right? This we call it as an array, overall array. This type of grouping is called as sub-aggregate grouping. When sub-aggregate grouping, if you don't supply enough initializers for a given group, the remaining members will be set to 0 automatically. Here, two square value is 4. How it is set to 0 automatically? Let's see with another example. Fine. What happens if a row has fewer values? Here, 3 and 2. I have explained about the sub-aggregate grouping, right? In the same way, you can observe here only one element is present in this braces and here only one element, right? Here, the second values becomes automatically 0. Then C will automatically set missing values to 0. That is, we get output as 1, comma 0 as here the second value is not mentioned or taken, it automatically considered as 0. And in the same way, in third row, 3, comma 0. Therefore, we can say a 2D array is like a table, rows and columns. You can initialize it with or without braces. Use expresses for each row is called as subaggregate grouping. This is an example, another example for subaggregate grouping. If you leave out values, then C fills the missing values. 0. As it fills here. Here 3. I have only mentioned 3, but it is filled with 0. Fine. Next concept is unsized array initialization. The word itself says the meaning unsized. Here the size is not mentioned. That array initialization, how we are going to do, that is the concept. Here array is declared without specifying size. Compiler automatically decides the size based on the initial values. Why we use this unsized array initialization? Because no need to count characters or elements manually, right? We no need to count or how much is there, how many are there, how much we have to assign like that. There is no confusions, and then it prevents errors from wrong array sizes and makes code cleaner, flexible, and easier to modify. Here is an example. Chat 3 of 1. You can see the space is left empty. Here the size is not mentioned. Read error. In the same way, these are some of examples. Compiler calculates exact size including the character also. Here is an example. Printf %s a particular string as length %d. Here E2 goes to %s and size of E2 will comes here. Then the output is write error. E2 is what? Here is an E2, right? Write error. This is mentioned as length. Length is %d, size of E2. How much is the size? That is 13. Shall we count? 1, 2, 3, 4, 5. And here 3, 4, 5. It ends with null character. And again it ends with null character. Totally plus 1. The total size is length 13. This is an output for this statement. Only the inner dimension must be specified. The left dimension is automatically determined. Here, int squares, this is leftmost dimension and here is 2. If you left one dimension as it is empty and if you mention another one, also the compiler automatically takes, but the condition is only the first dimension should be left empty. Here, the advantages of this declaration over the sized version is that you will length or shorten the table without changing the array dimension. Okay. The last concept for the day is variable length array. That is variable length array in C89. There are two versions, right? One is C89 and another one is C99. In C89, array dimension must be declared using a constant expression. Thus, in C89, the size of an array is fixed at compile time only. But this is not the case in C99 version because C99 version adds a powerful new feature to the array, that is a variable length. Here, the dimensions are specified by any valid expression, including those whose value is known only at a runtime. Okay, this we call it as variable length array. Here, however, only local arrays, that is, those with block scope or prototype scope, can be of variable length. First, let's understand what is this block scope and prototype scope. Here, block scope is nothing but that an identifier is accessible only within the blocks of code where it is declared. Suppose I have declared a identifier or a variable in this block of code. Then it is accessible only within this block. This we call it as block scope, right? Here the lifetime, what we can say? Here the variable is created when block is entered and is destroyed when the block is exited, right? The next scope is prototype scope. What is mean by prototype scope? Here, it is very specific type of scope that applies only to parameters names declared within the function prototype or declaration, that we call it as prototype scope. Why this prototype scope is used? Here it are purely for documentation purpose or ignored by the compiler. Only the type of parameters here it is mattered. Okay, here the specifically for parameters we will use prototype scope. Here is an example of variable length array. Wide and is a function. Here a variable length character array. Char, str and dimension. Here, the size of str is determined by the value passed to f function in dimension. That's what you saw that in code, right? Thus, each call to f can result in str being created different length. So, one major reason for the addition of variable length array to C99 is to support numeric processing. But you want to remember one thing, that is variable length array are not supported by C89 or by C++. Fine, this is the point. That's all guys for today's video, and next chapter I will be starting some next videos. For that, stay tuned. If you found this video helpful, don't forget to like the video, share it with your friends and subscribe to Explore Electronics for more such concepts. See you in the next one guys. Bye bye.